Okay, back for part 2 of section 8.9 to finish unit 4. Can't go a whole video without doing that, unfortunately. Anyway, let's get back to percent increase, percent decrease, and we'll pick up with problem 18 at the very bottom of page 495. All right, it says each year employees at LW Financial Group get a cost of living raise, a cost of living or cost of living adjustment, sometimes abbreviated COLA, like COLA. They say this year the raise is 2%. So the question is, how much will the new salary be for an employee making $47,000 a year? So, cost of living raise. We're talking about an amount of increase here that a person is going to be given, and it's usually based on a certain percentage of their salary. I can tell you the place where I work, usually most of these kind of raises tend to be, most of the time, not always, but most of the time, it's either the maximum of $2,000 or 3% of your annual salary. Okay, so that's not always the case, unfortunately, but most years, if things aren't tanking, it is. So here, it's just a straight 2% for everybody. Typically, it is going to be a percentage of your actual income. Okay, so it's 2% here at this place. The amount of increase, again, generally speaking, it's equal to the percent increase times the original amount. Now, the original amount we're looking at here is the person's current salary, $47,000. Okay. The percent increase, as I told you in the problem, is 2%. Now, what is this ultimately going to give us? This is going to give us the amount that this person's salary is going to be increased by based on this cost of living raise. Okay, it's not going to give us his new salary. Let's say his. Yeah, the same employee. Sorry, didn't mean to sound sexist there. It's not going to give us the brand new salary for the employee. It's just going to give us the amount of increase on top of this that this employee will make in the next year. Okay, so take your 2%. Convert it to a decimal so we can do this arithmetic. And we get 0.02, and that's what we will multiply to 47,000. So again, that's going to be $940 or something, but you don't have to do this in your head. You don't have to do it on paper. At this point, even if you were still in class, you could use your calculator, and it looks like you get $940 indeed. So this is going to be the amount that this person's salary is increased by. Okay, this is obviously not going to be the employee's new salary all of a sudden. Okay, that'd be kind of a shock going from this down to this. No, this is the amount we're going to add to the employee's current salary to get his new COLA adjusted salary. Going to take his or her original salary, you will add the increase to it, and you will get the brand new salary for the employee based on their cost of living raise adjustment. Okay. So again, amount increase, amount decrease. That's all this formula gives you, is that particular amount. If you're looking for a final new increased amount or a final decreased amount, you will need to take this, and like we saw in problem 16, subtract it from the original amount. As we see here in problem 18, add it to the original amount. Okay. The other relationship based on amount equals percent times base, although it will look a little bit different than that structurally, is simple interest. This is not really a format that's used by any bank or lending service typically. Usually they have much more complicated schemes that require some very advanced math to get through. But anyway, simple interest though is expressed by the following relationship. Interest is equal to principal times rate, or interest rate. Let me just do it fully there, I'll say it. Usually I'll just call it rate though, but we'll call this the interest rate, this one time, multiplied by time. Okay, usually they abbreviate this as I equals P times R times T. Okay, and that's great. But what do all these things mean? Because this might be the least straightforward formula as far as what all of these things refer to. Commission's probably the next most, confusing. So I think a lot of people, when they think of commission, they automatically think of a percentage. And yes, that is associated with the concept of commission, but commission itself is the amount of money you earn. It is based on a commission rate and sales, as we saw earlier. Interest. This is either the amount of money borrowed or invested. Okay. Oh my gosh. I did not start with the right thing. I apologize. That's the principal. Please forgive me. Sorry, I kind of in an old mode of teaching. Usually I go P, R, T, and then I talk about I at the end. I apologize. Principal. The principal is the amount of money borrowed or invested. Sometimes he or she is also the person you stick one funny note on their back and people laugh at them and spit on the hallway. No, but anyway, in this context, principal is the amount of money you are investing and hopefully getting a return on, or the amount of money you are borrowing and then you have to pay some extra back to the person or institution from which you borrowed. The interest rate is kind of straightforward. Obviously, as we've seen with other rates, this is a percent extra owed on a loan. Well, I don't want to say this. Let me phrase this a little differently. This is a percent of the principal that will be owed on a loan or earned on an investment. Obviously, if you are investing and hoping to earn some money, you would like this rate to be higher. If you are borrowing and need to pay back some additional amount on top of this, you want this percent to be lower, okay? So you are applying this percent to the principal. So the principal, in effect, is your base. The interest rate is your percent, okay? But you also have this other factor of time in this equation. This is simply the duration of the loan or investment. Now, in many cases, this is simply going to be 1 year. Why? Mainly because this is simple interest. Yes, you could do simple interest for a period of years. There's no doubt about that. But usually with simple interest, you have one application of the interest rate during this whole period that the loan is held or the investment is held. That's typically going to be 1 year. What is kind of important is that the units of time here match the amount of time that you actually apply the interest rate to the principal. Again, usually it's once a year, but let's say you hold an investment for 1/2 of a year, and typically you apply the interest rate to the principal once a year. Okay, this needs to be 1/2. This needs to be 0.5. Okay, very rare that we're going to see discrepancies like that. Maybe we might see them. We'll see. Okay, in the end, after you take the principal, you apply the interest rate to it and multiply it by the duration at which you hold the loan or investment. You get a certain amount of interest. Okay, what is the interest? The interest is the amount earned. When I say amount, I really mean monetary amount. The amount earned on an investment or the additional amount owed on a loan. Okay. So, principal. This is analogous to the base in amount equals percent times base. The rate is the percent in amount equals percent times base. Then you have this other little goofy factor of time that comes into play. Oftentimes it's negligible. I say that because typically most of these investments are held for 1 year. You typically apply the simple interest percent once during that time and it's over with. So oftentimes time will just be 1, and anytime you multiply by 1, it doesn't really factor into the final amount. So most of the time it is amount equals base times percent. That's what interest is. It's analogous to the amount in the amount equals percent times base formula. What it refers to is the actual monetary amount you earn on the investment. It doesn't tell you the final amount you have from the investment, just the amount you earn on what you invested. Or in the case of borrowing money, God forbid, but in the case of borrowing money, because I've done that one too many times and it's not very fun. Luckily I don't have student loans, but I've done it twice since getting married. Otherwise, if you borrow money, this is the extra amount you have to pay back on top of what you borrowed. Okay? So, this is kind of very important to understand all of these, what all these variables, if you will, in this formula represent or refer to, because it'll kind of help you digest some of these problems a little bit more easily as you read through them. Okay, so again, interest is a monetary amount just like commission. It's the commission rate or the interest rate that tells you, hey, what are you charging on top of the principal or the amount of sales? Okay. So let me erase these boards and let's look at a couple of examples. Check time really quick. Okay, plenty of time. All right, problem 24 on page 496 says the following. A teacher's credit union gives $300 short-term loans to low-income students for money to buy books, supplies, and materials. If the simple interest rate is 6%, how much interest does a student pay if the loan is paid back in 3 months? Okay. So again, page 496, problem 24. All right. So They tell you the amount of the loan here. It's $300. Okay. That is your principal. Okay. They also tell you the interest rate. That's 6%. Keep in mind, to do arithmetic with this, we will want to convert this to the decimal, 0.06. What else do they tell us? They told us the time is 3 months. Now, I would kind of understand that the context of this problem is as follows. Generally speaking, most of these loans are probably due within a year. Okay, you borrow the money, they expect to have it paid back in a year. And so the idea is if you pay it back a little early, you'll pay back a little bit less of the amount if the loan is not held for a full year. So the question is, what fraction of a year is 3 months? Well, most of you know there are 12 months in a year. Which gives us 1/4 if we reduce 3/12. So this loan is being held for 1/4 of a year. Okay, 0.25 if you want the decimal for that. Okay, but again, we can use fractions. Okay, it's not a problem. Fractions, decimals, they mix arithmetically, just not percents. So let's go ahead and calculate all this. Okay, and all they're asking for is the interest, right? If the simple interest rate is 6%, how much interest does a student pay if the loan is paid back in 3 months? So we're not asking for the final payback amount, just the interest that the student accrues on this loan. So it's going to be $300 of principal times a rate of 6% or 0.06 as a decimal times 1/4 or 0.25 if you want to use that. But it shouldn't matter. Your calculator can hopefully handle all this. And let's see what it is. So 300, like a 4.5 out of this maybe. So 300 times 0.06 times a fraction 1/4 is, 9/2 or 4.5. So again, you can technically cancel 4 into 300. 4 goes into 300 75 times evenly. 75 times 0.06 is 4.50. Okay. I'll just double check that too. Yep. So this student is not accruing much interest at all on this loan. He or she paid it back so quickly. So they borrowed 300. They only have to pay back this much extra. Okay. You can probably scrounge around for some loose change just to get that much interest. So $304.50 would be the final payback amount. But all they really care about is just how much interest the student accrued on the loan. And I won't purposely go over this example because this is one example where the time is not equivalent to the compounding period of the interest rate. Simple interest, the compounding period is just 1 year typically. Okay. And if you are paying a loan back sooner than that, well, you should be accruing less interest on that loan. How does that get factored into play? With the time part of this formula. Okay. If you are not holding the loan for the full year, but only a fraction of the year as we're doing here, you'll pay back less interest on this loan. Okay. So, but again, that's all they want. They don't need the final payback amount. But as I mentioned earlier, if you do need to calculate this for another problem, you'd have to take this additional amount, add it to your principal. That would be your final payback amount. But here, they just wanted us to calculate the interest on the loan, and that was it. Okay, but again, This is the one big wrinkle, and it's not one that you'll see in most of the problems. Again, that's partially why I chose this one on purpose to go over as an example. Most of these, the time is just 1 year, and it's doesn't really come into play. Okay, so again, principal $300. That's the amount the student borrowed. Interest rate was 6% or 0.06. Time was a fraction of a year. If you multiply all those together, interest is principal times rate times time. You get the interest. What about 28? This might be a little bit more of a interesting question too. Because again, they're not asking for a final payback amount or whatnot. I think they're asking for, a person's borrowing money and they're paying it back. How much do they need to pay back on average each month to get the loan paid off in a year? So 28 on page 496 says the following. Alicia gets a business loan of $8,500 at a simple interest rate of 9% for 1 year. If she pays back the loan in 12 equal payments, how much is each payment? Okay, so we do need to apply all this stuff to this problem, but then we're going to have to go a little bit further than that to actually answer this particular question. So first and foremost, they told us her business loan was $8,500. So again, the amount you invest or borrow, that is the principal. They also told us the rate of this particular loan was 9%, which again, obviously we'll need to convert that percent to a decimal to do the arithmetic with it, is 0.09. And this is a very typical example of the time just being the 1 year, that 1 year compounding period for the interest rate. So we don't need to make any goofy adjustments like we did back in problem 24. Okay, again, usually they compound or apply is what that means, the interest rate once per year to the principal. Okay, so if you hold it for 1 year, no goofy adjustments are needed for the time. So we have all this information here that was just directly given to us. We can calculate the interest, which in this case, because we're talking about a loan, this is going to tell us the additional amount Alicia must pay on top of the $8,500 that she borrowed. Okay. So we're going to calculate that by multiplying the $8,500 by 0.09 for the interest rate. And then again, multiplying by 1 at the end is not going to give us anything different than taking 8,500 times 0.09. Okay. So I did 8,500 times 0.09 in my calculator. We get $765 for the interest. Okay, now that's not the final answer. I'm circling that for now just to keep it in mind. Question is, Alicia wants to basically figure out how much does she need to pay month by month over this year on average to pay off not only the $85 she borrows, but the $765 of interest she accrues on this amount. Okay, so what we want to do is we want to add the $8,500 of principal to the losing the ability to talk, to the $765 of interest that she has to pay back on top of that loan. And her final payoff amount for this loan winds up being $9,265. But again, she doesn't want to pay it back all at once. She wants to give an average monthly payment over the course of the next year that will equal this amount. So what do we need to do? We simply need to divide this amount by 12 and round to the nearest penny if necessary. Okay, well again, use your calculator for this. 9,265 divided by 12, I get 772.08, and then I just get 3 repeating, on and on and on and on and on. Now, because we are dealing with monetary amounts here, it's just kind of always implied or assumed we're going to round to the nearest cent because we don't have any more precise form of measurement for our currency. Years ago, there used to be like half cents and things like that, and 2 and 3 cent pieces. But nowadays, and it's been this way for a very long time, penny is the lowest or most precise unit of measurement for our currency. The penny is represented by the hundredths place when you write the dollar amount out as a decimal. So if you ever are needing to round a monetary amount, round it at the hundredths place. That represents rounding to the nearest cent or nearest penny. So I get for a final answer $772.08. Okay. So there's really a lot going on in problem 28. Yes, we are doing the usual application of the simple interest formula with the numbers they gave us, the loan amount, the interest rate, the time. But they didn't just ask us for the interest. They also didn't just ask us for the payback amount either. Oh no. We need to take that principal, the amount she borrowed, we need to add the interest to it to figure out her final payoff amount. But because they want us to figure out, well, how much does she need to pay back on average each month to equal this amount after 1 year, we need to divide this total payoff amount by 12 for the 12 months in a year, round it to the nearest penny or cent. Okay, it's a very interesting problem. Even though, again, like I said, simple interest is not really highly applicable in daily life. Very few instances. I don't even know if any. I don't know if the banks even do anything like that anymore. I know all of my loans have never been like that, but nevertheless, it kind of gets people thinking. If you happen to go on through algebra a little bit more, you'll look at more complicated interest formulas. I think maybe in pre-calculus algebra, perhaps. Things that get a little bit closer to mimicking real life here and there. But again, certain interest formulas are so complicated, it takes generating functions and solving them and using calculus to figure things out. But anyway, if you have any questions about some of these problems, let me know. Again, obviously I have the formulas at your disposal in the book. I'll give you the formulas on the test nevertheless. Outside of that, if you have any questions about the homework or something in MyLabs Plus, just let me know.